This table right here, what I want you to do is you're gonna copy down the word problem, and you're gonna copy down the tables on that where you took your notes, and do it exactly as it is on the board. Do it exactly as it is on the board. Label them the same way. So it says a 120-pound person would weigh 20 pounds on the Earth's moon. A 150-pound person would weigh 28 pounds on Io, that's capital I, lowercase o, a moon of Jupiter. Use a ratio to determine which moon makes the person weigh the most. Okay, so it says a 120-pound person would weigh 20 pounds on the Earth's moon. So we're going to focus on that first. So the first ratio on here, what's it going to be? Armstrong. Armstrong. Okay, and what's the other part? No, well, you got this part right. How about 20? So we got that right? That's what's supposed to be in there, because that's your starting ratio. They told you right there, a 120-pound person on Earth will weigh 20 pounds on the moon. What's up, Wyatt? The Earth's, this is the Earth's moon, this is Io's moon. All right, so the next value, what can we get the next one? What do you got, Parker?
240 on Earth and 40 on the moon.
There you go. How'd you get that?
I just multiplied.
Okay, so he went this way. So he's doing the multiplicative method. So what do we got next? You can do the additive method too. What do you got, Maddox?
360 and 60.
There you go. So he went from here to here. Now we only require you to do the two values to show your work, so we know what you're doing. What's the next one, Graham?
480 and 80.
Okay, who's got the next one? Anybody on this side? We got Hayes. Hayden. Wait, Hayden. A little off. Hayden.
Yeah, the first one would be 600, and the next one would be 100.
There you go. Okay, next. What we got, Parker?
The Earth would be 720 and the moon would be 120.
Okay, last one. Somebody over here. Jake.
840 and 140.
There you go. Okay, so we got that first one built. Now we're going to work on the second one. So a 150-pound person would weigh 28 pounds on Io. So what would be the first values in here? We got Maddox.
150.
And?
28.
There you go. All right, who's got the next one? We got Dylan.
386.
Okay, how'd you get that? Okay, so he went here. Okay, is that the next one? Bryce has his hand up. He's getting tired. That's correct. So he went from here times 3, and from here times 3. All right, who's got the next one? Parker.
Earth will be 600, and Io moon will be 120.
Okay, good. Who's got the next one? Who's got the next one? Go, guys. Now you know this. Parker.
Earth it would be 750.
Okay.
And the moon it would be 140.
Yep. All right, who's got the next one? Mia.
900.
Yep. Who's got the last one? You may. $1,050. $196, correct. Okay, so now that we have our values in the table, what we're going to do is compare them. So if you're looking at both tables, what numbers do you see that are similar that we can compare? Abby?
The 600.
The 600, so she's looking right here. All right, so what she's saying right here is a 600-pound person on the Earth, if you put them on the Earth's moon, they would weigh 100 pounds. And that same 600-pound person, if you took them to the Jupiter moon Io, they would weigh 112. So looking at that comparison, which moon makes you heavier? Get somebody else here. So we got JJ. Yes, that's right. Io, the moon of Jupiter, because it makes you 2 pounds heavier, right? Does everybody see that? Okay. And that's how you compare ratio tables. You look for the similar one, and then you compare. Okay, I made a mistake. It's the end of the day. I make mistakes. It's 12 pounds heavier. Sorry, not 2 pounds, 12 pounds. But there you go. Thanks, Parker. Okay, on this one right here, we're going to create 4 equivalent ratios. 2 by scaling up and 2 by scaling down, using the ratio 30 to 80. So that's going to be our starting point. What do we do when we scale up? If we scale up, what are we doing? Jake. That's right, we're increasing the number. So what do we do when we scale down? Decreasing, right. So here we're either going to add or multiply, and then on scaling down, we're going to divide it down. Subtract or divide, correct. All right, so you know that this is our starting value right here, because it tells you that. You can give me the next one in the table. If we're scaling up. Dylan.
50 to 100.
Okay, what'd you do there?
I added them both together.
Okay, so he went here. All right, next. Parker.
90 to 240.
90 to 240. Again. Plus 80. All right, so we were only supposed to do 2, but we're going to do 1 more. Yeah. Yes, the 320.
320.
Yes, 320.
Yeah.
All right, so now we know that right here when we're scaling down, we're starting right there. So who can give me the next one? JJ. Not a little off. Somebody? All right, let's make this easy. Dylan. We're gonna little, yeah.
22.
You guys are making this too hard. Look at that. All I did was, what did I do?
You divided by 2.
Or minus by 15 and minus by 4.
Okay, so we divided by 2. Now, what can we do with this one? Lily. Anybody have it? Who's out there? Mimi, you got your hand up. What do you got? Divided by 3? No. What do you got, JJ? Divided by 5. There you go. This thing doesn't want to work. There we go. So this is going to give us, there you go, 3 to 8. And now you can't go any further than that, so that's simplest form, right?
Yes.
Okay, so on page 42, you have this table in the book. What can you tell me about these ratios? Yes, Wyatt. Okay, we'll get back to you after that. Hey. Okay. So JJ. Yeah. Okay. But what is this? What's the term, Armstrong? Okay, but there's a term that I'm looking for, Lily. No, not exactly. Dylan. No. They could be additive as well. Abigail. Okay, guys. You guys are forgetting, what are all these? They're all equivalent, right? They're equivalent. Okay, so they're equivalent, so there had to be a starting point somewhere. So who can tell me what the starting point is, Jaden?
20.
There you go. So, they're equivalent because our starting point was 1 to 8, which means for every 1 hour, 8 pizzas are sold. Everybody see that? All right, so now we're going to compare 3 different tables to find out the data that we need. So the following tables show how many words each person can text in a given amount of time. Compare the rates of texting for each person using the ratio table to determine who is the fastest. All right, remember when you took your notes, the first thing we want to do is try to find similar numbers. Dylan.
Maria and Michaela both have
3s? Okay. So he's looking right here. All right, so looking at those numbers, who's faster, Michaela or Maria? Alex. Are you sure? Hey. Why? That's correct. Michaela's faster because she can do 150 words in 3 minutes, and Maria can do 120 words in 3 minutes. So she gets a 1, She gets a 2. Okay, let's see if we can get Jenna involved. Let's see if Dylan.
Maria and Jenna both have 6s.
Okay. So here and here. So out of those two, who's the fastest? Riley.
Maria.
Are you sure? Sarah.
Jenny.
Jenna, right? Why?
It says 270 and Maria.
Okay. So out of these two, Jenna's faster and Maria's in second place again. Now, out of Michaela and Jenna, who's fastest? How can we tell? Mia.
Michaela's faster because she multiplied 3 by 2.
Which one? This one?
Yeah, 3.
Okay. Which we get to 6.
And 150 times 2.
It's 300, right? So now you can compare them. See how she did that? She did an extension. Jenna has 6 minutes, 270 words, and what Mia did was she looked at Michaela's, and Michaela has 3 to 150, and all she did was double it, and that gave her 6 to 300. So now she can compare. She can compare this and this right here, and she can tell that Michaela's faster and Jenna is second. So just looking at that, who's the fastest? If you looked at what we have here, Armstrong. Okay, so Michaela would be first. Who would be second? Jaden.
Jenna.
Jenna would be second, and then Maria would be third. Okay, another thing you could do right here. Check this out. We can simplify this, right? Because we divided by 3. You can simplify this one right here. We divided by 2. And you simplify this one. See what we did there? So for every 1 minute, Michaela can do 50 words. For every 1 minute, Jenna does 45, and for every 1 minute, Maria does 40.
I know that makes sense.
You can do that as well. Now that's not always going to work out, but it just happened to work out here. But you see there's different ways to solve this. We looked at a bunch of different ways to compare.
So that first it looked like Maria was faster than Jenna.
Yeah. So, and even though we did all this right here, and we ranked them, if we broke it down into simplest form, it still came out the same, right? The order. So there's many ways that you can solve this problem. Any questions? All right, so this table right here on page 43. Complete the table so that it shows that Max has a texting rate of 55 words per minute. So what are we going to start off with? Elise. 1 and 55. There we go. So that's our starting point. So we are going to scale up. So who has the next value? Let's see who we got here. Maddox, what do you got? You're right. How do you do that?
I added 1 plus 1, and then I added 50.
Okay. Next. We got the next one. Parker.
3 minutes and 165 words.
There you go. So again, plus 1, plus 55. All right, who's got the last one? Maya. That's correct. 4 and 220.
Guys, don't forget to show your work. He's showing you what you should have on your paper.
Remember, we got to do the first 2, and then after that, if you guys want to do it in your head, that's fine. I would recommend that you keep showing your work so you don't make a mistake. Again, you can use the additive or multiplicative method to find the ratio.
Like this one, I like this problem because it's got a lot of moving pieces, and as so many of you learned on your quiz, understanding the directions and following the directions are really important, right? And how do we do that? We start by marking the text. So if we mark the text on this one, everything that we're supposed to do should pop out pretty quickly. So the tables below show you a comparison of the amount of water to the amount of juice concentrate in the grape juice made by 3 different people. Whose juice has the greatest amount of water to juice concentrate ratio, and whose juice would taste the strongest? Be sure to justify your answer. So there's 2 things we need to do in here, right? What are they, Gillian? So I know you were marking your text right along with me, so you have the 2 questions underlined and know exactly what we're talking about, right? Okay, so 2 of them. Whose juice has the greatest amount of water, and whose juice would taste the strongest? Is that the same question? How do I know whose juice tastes the strongest? Are they going to have more water or less water, Armstrong?
Less water.
Why?
Because the more water you put, the less the solution is.
You guys ever heard the term watering something down? Makes it taste less strong, right? So that's the whole idea. If I put more water, the taste is going to be weaker. Make sense? Okay. Now, one thing I don't like about this is after they did that, then they do this, put the juices in order from the juice containing the most water to the juice containing the least water. Okay? So this is kind of the first part, not the second part. So what we're really looking for, guys, who has the most water? So who's got some numbers on here to help me understand who's got the most water? Okay? Laredo's has the most water? But what's the key when we're comparing? What do I have to do to have a comparison? What do you think, Lily? Okay, I got different ratios in here, right? So I can't just look at one number. I have to look where they're the same and compare the other number. Make sense? Okay, Sarah, do you see 2 numbers that are the same?
Yeah.
Where?
The middle one and the last one.
Okay.
40 and 40.
40 and 40, good. So she's down here. Okay, given that, who has the most water to juice? Franca or Milton? Why do you say Franca?
What is the most water?
Most water to juice.
Sorry, Milton.
Why do you say Milton? So, we're looking water to juice.
Oh, because it says 10.
Okay, so 10 is smaller than 8.
No, larger.
So if it's larger, does that mean that the water to juice is bigger or smaller?
Bigger.
Jaden, help her out.
Well, it's smaller because the water makes it less strong.
The water makes it less strong, right? So to say which one has the most water, do I want less juice or more juice? Less juice, because that means they have more water to juice, right? So who would that be, Franca or Milton? Franca, because she's only got 8, Milton's got 10. Make sense? So here's part of the problem on these guys is not only do we got to make the comparisons, we have to understand what the comparisons are. And you're only going to get that by reading and understanding the directions. Make sense, Killian? Okay, who sees another number we can compare? What do you got for me, Dylan?
Doritos and Milton, they both have 4.
They both have a 4, right? Okay, so who has the most water to juice? Go ahead, Dylan.
Milton,
Why do you say Milton?
because even though they have 4 cups of juice altogether, but Milton has 16 cups of water, but Rita, what?
But then we just picked Franca because she had 8 instead of 10. So now why are you changing it on me?
Oh, Rita has more?
Does he? You have to know. Guys, I'm going to question you whether you're right or wrong. Because if I only question you when you're wrong, you're always going to know that, oh, he's questioning me, I must be wrong. You may be right, I'm still wanting you to verify why you are right. So Dylan, you want to try again? Why are you right? What's the difference? What were we comparing the first time, Dylan? Right. What are we comparing this time? No, juice to juice. Well, okay. This time we're looking at juices the same, but now we're comparing the water. We're comparing the other way, so our scale is different. You were absolutely right, Dylan. Milton has more water than Laredo. So Milton beat Laredo. Do we need to go any further? Do we have to have a comparison between Franca and Laredo? Why?
Because then you won't know who's first or who's second.
We don't? Franca beat Milton. Milton beat Franca. Or Laredo. Is Laredo going to beat Franca?
Yes, because he's 1. He's number 1.
No, he's number 2.
But Franca's number 1.
Franca's number 1. Will Laredo beat Franca if he already lost to Milton?
No, because Franca has more
So
than Milton.
technically, do I need to do any more comparisons?
No.
Right now, I already know my order. Now, if you want to do another comparison, you should be able to, right? Do you see any numbers here or here that are the same? Yes? There's 5s.
There's
And then there's
15.
15.
There's 15, so we can do either way. Now, given what we're trying to compare, it will be easier if you find the juices that are the same, because it just makes more logical sense. If the juices are the same, I want the guy that has more water, because they beat him, because they have a higher water ratio. He's got 25, he's got 15. So just as we expected, Franca beat Laredo. So can we put them in order now for like 100% confidence? Yes, we should be able to. So putting them in order, the most water was Franca. So the order is Franca, Milton, then Laredo. Okay, there's one other way we can look at this, and that would be going to simplest form. So if I take my initial value and simplify as much as we can, you should be able to see something else. So 12 and 4, what can I reduce both those by, Bryce? I can divide 4 by 3? 4? So I divide them both by 4, that gives me 3 to 1. 10 to 2, what can I reduce both those by, Armstrong? 2, that gives me 5 to 1. 8 to 2, what can I reduce those by? Dylan? 2, that gives me 4 to 1. So if I go to their simplest form, then we can also see 5 beats 4 beats 3, right? Okay? Now, that's not always going to work, because sometimes they don't all reduce down to the same number. But if they do, then that is a third option that you have to be able to do that.
That's another way to make sure you're correct.
Another way to make sure you're correct. Does that make sense to everybody?
Yes.
Good. Okay, let's look at the next questions. These are right down here. So, explain how you use the values in the table to determine the order. So what were we doing? Yes, Jake, but how? What? What about the table were we looking at? Which values? Which values were we looking at?
The totals.
Did we really talk about the totals? So what values were we looking at?
The water and the juice.
And then how did we use that to determine the order? How did you determine that Franca had more than Laredo? Parker?
It's because the question was asking who had the most water to use, and
So how did we use the values to determine that?
so we found the same values in the water.
Okay.
40 Francis and Milton's, and then we compared who had less and who had more.
Good. So we found the same values, then determined who had the most water at that point. And that's really significant because, sorry to make a point on this, hey, but hey just looked for the biggest water value. Was that what we used? No, we had to say at the point, at a common point, who had the most water. Make sense to everybody? Is there anybody that doesn't understand that? Okay? Again, it has to do with reading the question and understanding what we're being asked. So what ratios were used to create each table? We actually gave that to you. That was 3-to-1 for Frank Laredo, right? 5-to-1 for Franca. And 4-to-1 for Milton. Okay? So how could the ratio help us compare the juices? Someone other than, there you go. Alexander?
By looking at the first number.
Good. By looking at the first number, which represented what? Good, the number, the water. Okay, you got all that written down? Okay. Okay, unfortunately we're basically out of time, guys, so I want everybody to really quickly jump over to page 46. Here's your homework. Number 1, use the ratio table below to determine who the faster swimmer is. Okay, I'll give you a hint. We don't find the same number, but there are a lot of ways to combine two of the numbers from one to get you a number that is an easy extension to compare to the other. You also have the option of simplifying, but for me, it's actually really easy to find some numbers that are going to add up and to be able to compare. Now, whichever way you use, explain the method, right? So part B, tell me how you did it. So part A, I do need an answer who the faster swimmer is. Part B, tell me how you did it. Make sense? Part 2, that should look really familiar to everybody. Hopefully you took good notes today. If you took good notes, we just did half of your homework for you. You just have to copy it over to this page.
Yeah, because it's the same question.
Okay? Questions on the homework? So, you guys should be able to do this homework really quickly today. Anybody tells you take more than 5 minutes, I'll be really worried about you.
By the way, Mr. Moore,
Yes?
what about the quiz?